Hi everyone. Hi everyone connected like remotely. Hi everyone here IRL. I'm really happy to have here like a guest lecturer for the Learnathon that we are attending, like we are organizing here about fast AI and how to learn to run your first deep learning model. Um, I'm really happy to have not only a guest lecturer, but a friend. We met like 10 years ago, something like that. And, I think I perceive that is like a past life, both for me and for him, probably. At the same time, this past life make a lot of sense now because I feel here that I feel that we are here at Network School, and the Network School. I feel like we are, like new monk building new civilization, kinda seeding new civilization, and um, I feel that this past life that we had in common together, so it's really something. It's really something that is connected to this new novelty that Network School is bringing to the world. Um, but maybe Jonah will tell something more regarding his background later. So let me introduce him. So Jonah Lynch is the founder of Innovation Lens. Innovation Lens is a fresh startup and has a very interesting and ambitious mission which is like predicting future trends in science that not really exist yet. So they are using like LLMs, artificial intelligence, and space latent math to predict like future trends, and using like public data, which are public paper in scientific research and stuff like that. So Jonah today will guide us through this topic and will guide us through a demo of his platform. And also, I hope that soon will be physically here and teaching us more cool stuff about science, about AI. He has a very diverse background. I truly believe he's a polymath, so coding since the age of 7, with 3 masters, 2 PhD, 1 PhD in AI applied to history and historiography. So really cool. I'm really excited. Thank you, Jonas, for being here. I know that it's the evening for you in California, but yeah, so the stage is for you, and thank you so much for being here.
Well, thank you, Leo. I really appreciate the invitation. Is it possible for me to see who's there present? Otherwise, I'm just talking to you and a bunch of bots.
I know. That's the downside of technology. I promise that we are here with an interesting crowd. We can flip.
Yeah, just turn it around for a second.
Yeah, I just flip. The problem, I don't want to. So the cable is pretty okay. You can see the guy.
I can say hello. Hey guys. Hey. Now I feel like I'm actually in front of people. That's wonderful.
Perfect. Okay, I keep the screen like that.
All right. Oh, it's cool. That's nice. I appreciate that. All right. So I appreciate the introduction, Leo, and I want to start by talking about the problem that motivated me to do this work, and then I'd like to talk a little bit about the theory and practice of how it works, run you through a demo, and then leave ample space for questions, because I think that's the most interesting part usually, is like, what do you care about and what do I know and how can we meet, so that's what I'd like to do. So to start with, I'm going to talk a little bit about the problem of information overload. And specifically, I was running into this problem while doing my second PhD, and I was working with a group of archaeologists, and these people seemed to really enjoy arguing. And I was becoming frustrated because I wanted to resolve the arguments. I was like, quantitative measures ought to help us to agree at the end of the day on something and resolve the questions, not just talk about them. So, I started doing some various procedures. You can read them in my thesis if you care. But the main point that I want to share with you is that I realized that there are ways to apply math to complex arguments, like the argument with these archaeologists. So using natural language processing and then graph representation, word embeddings, different tools that have been recently developed for natural language processing, it's possible to develop a model of the discourse. So I did my PhD on this idea of how do you model scientific discourse. And as I was doing that, I realized that the problem of information overload could be faced also through this way, which is, how can I take into account all the information that other people have discovered before me, but which I can't possibly read because there's just way too much. I mean, like the classical solution to that problem is specialization, but we know very well that specialization has a very big weakness in the problem that you can't do interdisciplinary work. And a lot of times the interesting things come out of what's between the disciplines, right? So there's actually ways to qualify scientific discovery as the thing that happens in the empty spaces. Like, it's the thing that the well-known areas are not where something new happens. The new things happen in the unknown areas. So I started to study this problem from a couple of different points of view and write code to build models. And the result is the program that I'm going to demonstrate in a little bit. But before we get there, the problem, I think, is clear. I think that anybody who does a little bit of research runs immediately into the problem that there's too much information out there. And you can be the diligent student and do your literature review, read all the articles that your professor tells you to read, and you're still barely scratching the surface. So, okay, that's problem number one. Problem number two is, how can you apply computation to something that is so slippery like human language? I mean, okay, so we in the last 3 years have become used to the idea that you can do a lot with computation and language, but I was writing before that, for ChatGPT, and what is possible? Like, what kind of measures could actually give us a bird's eye view of the network, a bird's eye view of the distribution of existing knowledge, and how much information would you lose in doing that? So these are problems that I'm not going to go into in depth right now, but I just want to have them present. So what I'm saying with that is that on the plus side, we can hope for an intellectual prosthetic. We can hope that we can create something that expands our vision and gives us the possibility to know more about the world, even within the limited span of human life, at least as limited as it is at the moment. And on the negative side, these methods are going to have a trade-off, right? So while we'll be able to gain a broader view, we're probably not going to be able to see things in as great a detail. And so my question then, like, second question became, how can you optimize where you place your attention? So if there's all this distribution of existing information and there's some kind of structure that maybe I can query using different mathematical techniques, how can I point my gaze to the things that are most likely to be useful? And that became my quest. More and more as I was studying that became the thing I wanted to do. So right around the time that I had put that question clearly in mind, well, I guess I had been working on it for about a year. ChatGPT came out, and I was already using language models, and the idea of text vectorization was familiar to me. But that really gave me a fast acceleration to try to understand if this technique could be applied to my problem, and if so, how. So let me just give you a high-level intuitive way to think about it. So if all the text that has ever been written is encapsulated inside of this language model, that's like, I don't know, one of the metaphors that I would use is it's like having a librarian that's read all the books in the library. They're very good at helping you retrieve the piece of information that you want. And also, there is some kind of synthetic knowledge in the space, because the fact that everything is embedded in a single space potentially means that there is structure in that space. There's structure in the way that the information has been embedded in the space. Maybe we can derive something useful from that structure. When Anthropic came out with their Golden Gate Claude, how many of you know what I'm talking about if I say Golden Gate Claude? Only one? Two? All right. Well, let me explain it then for those who don't know. So this was a very funny and very illuminating experiment that was done a couple of years ago by Anthropic, so the main competitor of OpenAI. Well, to a certain point, the main competitor. Anyway, what they did was they said, okay, so there's this space, right? The vectors, the word vectors are 1,000, 3,000 dimensions. They're very large. What happens if you add some direction to that? and you just shift everything over on one of those dimensions a little bit. So if you do that, they found that the directions in the latent space actually encode some kinds of high-level qualities or concepts, and they started talking about concept vectors. And so they ran this funny experiment where they found the concept vector, they found the direction in the latent space. It corresponds to the Golden Gate Bridge, and they just added a little bit of that vector to everything. So no matter what you talk about in this chatbot that they had, they would add in a little bit of the Golden Gate vectors. And Claude is the name of the chatbot. So Golden Gate Claude was the chatbot who just would not stop talking about the Golden Gate Bridge. If you asked him to write a recipe for chocolate chip cookies, he would end up talking about the fog and the Golden Gate Bridge and all this kind of stuff as well. So that was a very funny experiment. But the point that I'm making is that the space, the latent space, the space in which the words and the texts of all of human history have been embedded, contains also something in its structure which corresponds to a concept. And work on this is ongoing. There's a lot of really interesting research on this point. So just on an intuitive level, I'm not going to go into detail, but just on an intuitive level, we can say there is a connection between, there are some things in the latent space that are meaningful and that can be extracted using mathematical tools. So I started to think, how could we use that to start to query the spaces where nothing is yet? So the intuition is scientific discovery fills the space. First we go one place, then we go to another place, then we go to another place, and bit by bit we fill the space with discovery, with knowledge. And you can look at that as humans are discovering things. I'd like to make some kind of opposition. I'd like to say you could look at it as if humans are inventing knowledge. That there's the idea that we kind of construct knowledge about the world. But you can also look at it from a more classical point of view, which would say we are discovering aspects of the world and then encoding them using math or whatever tools we're using. If we're discovering something, so maybe there's a pre-existing world that science is discovering and describing, then it makes sense to think that scientific discovery fills the space, because bit by bit we understand what's in the space, what pre-existing things that are there, and bit by bit we discover them. If that's true, or something like it, then maybe we can also query the latent space of the language models and find out if people have written about concept A and concept B, maybe there's a concept C that lies somewhere in the middle between the two and has characteristics of the previous two, but also something else and something new. Okay, so now I'm getting close to talking about my program, my application and startup. So what good would that be? Well, it would be good as a scientist to have some help doing hypothesis generation. It would be helpful if after writing an article, or even before, like you're a PhD student, you're starting out your career, you haven't read that much. You've got an advisor who tells you, read this, read that, but it would be nice to have some kind of map saying, okay, these topics are finishing, these topics are starting. You can optimize your attention and your time by pointing your attention in this direction rather than that direction, right? So something like that. Or early career researchers, it would be nice to have a tool where you can say, I need to make sure I do something of high impact, and I don't want to waste my time because otherwise I'm not going to get tenure. There are lots of reasons to want the kind of tool that I'm talking about. From a more, those are all sort of self-interested points of view. From a more, altruistic point of view, there's the problem of resource optimization. This is also an important problem right now with a lot of funding being cut, for example, in the US government. All of a sudden you've got half as much resources. How can you do high quality work? How can you invest that in the best possible way? So I ran some validation. I discovered a pattern in the data, and I ran some validation last year to see if actually I had discovered something that could be valuable. And what I discovered was that if you randomly, actually, why don't I just share? I can share this this document so you can see it. It's not just words I'm giving you. Okay, so I'm pulling it up here, and then let me give you share the screen. Here we go. Okay, so I did some validation, and I discovered that if you go scattershot in the space and you invest your money, your resources, your time, your attention, the more things you attend to, the more experiments you do, the more money you spend, the more results you get. That's kind of obvious. The red line is randomly chosen points in space, and I'm trying to predict where do I get articles that get more than 1,000 citations. Okay, so on the y-axis, I've got number of articles over 1,000 citations, and on the x-axis, I've got basically a metric of investment. And what I saw was that my algorithm is beating that by, you know, a sizable margin in some domain. When we get to the end of this, the algorithm does less well than randomness, but that corresponds to basically filling the space with your randomly chosen experiments. So if you have unlimited resources, that is a more efficient way of doing things, but we generally don't have unlimited resources, so we're much farther down the range here. Okay, but you might object. In real life, people don't just invest randomly. That's not how you do research. You start within the tradition that you're in. You know, you've got you're within a discipline, and the discipline has its history, it has its knowledge, and you start there. Well, if we do that as our baseline, we actually get worse results according to the metric that I chose. So if you want to do new research, discover new things, high impact, 1,000 citations or more, you should not stay within the existing tradition. That's not a good idea, because here our line is even lower slope than before. So these are the safe bets where the research has already been done. There's not much new to do. Okay, so that gives you a feeling for what I was doing to prove that my model actually works, because there is actually a correlation then between my predictions and high impact articles. Oh, by the way, all those articles were in computer science. So my validation is true for computer science. I don't know yet for other subjects. I'm going to do that in a couple of weeks when I get my data. What else can I say? That data ends in 2020. So I did back testing. I said, I'm going to use all of my articles until 2020, 1st of January, to predict what happens in the last 5 years or 4.5 years. So that's the exact way that I did that validation. Okay. Information overload. Can we create some kind of telescope, you know, to be able to see farther than we can read? Because every month, 20,000 articles are published on arXiv, and you can't read 20,000 articles in a month. It's just not possible. So how can we face this? Second, the mathematical structure of the space where the articles are embedded, so a language model, contains information that is summarizing. So it gives us a way to focus on things that we can't analytically read directly, but we can summarize in an effective way. And also it contains pieces of structure that are predictive. In the case I just showed you, I'm able to predict future high impact articles based on the structure of the latent space. Finally, how can this be useful for scientists and researchers everywhere, and potentially also for other industries too, because this is really more than a product, it's kind of a proof of concept. But I'm going to show it to you because it is also a product, like it's ready to be used if you want, and let me just show it to you. All right, here it is. So this is innovationlens.org, and you can log in with your Google account or your GitHub, or just make an email account. And you start out by setting up, this is all for the demo because I had to reduce the data amount. So it's a little bit clunky, but I'm working on making the interface better. Anyway, let's choose archive. I don't know, how about computer science and math to start with? And then if you want, we can do another run through with your own choices. Then let's say we want to know something about optimization. Okay, we can add more keywords if we want here, but I'm just going to stick with that because I know it makes a pretty picture. And it'll take a little bit to download the data because we're querying 10 million articles here and separating out what we want. So here we go. Computer science in pink and the other one, math in lavender. I have summaries here which are written by an LLM. So they're sometimes good. Sometimes we have these bad things like, here are 3 or 4 words to label the abstract. So I'm going to have to do some work on the prompting there. But anyway, as we zoom in, what we can see is the structure of all the optimization articles. That means that the title or the abstract contains the word optimization. So that's the filter that's happening here. And you can see that there are parts which are mostly math. This is mostly the purple color. And we have parts that are mostly computer science, and there's also an interface between them. So this was the first idea for the tool, was how do we provide a way to look at how two disciplines are interfacing with each other? Where do they touch, on what subjects? And then how can we apply my algorithm to try to see what topic in that area would be most useful, most interesting? All right, so I'm just going to choose something here that looks interesting to me, and then we'll do one together where you guys can. How about sparse graph optimization? That's an interesting topic. Okay, so as we get down to small dots disconnected, we start to be able to see the title and the abstract, well, just the title and the first author, but there's also a link. So we can go to the link and we can see the page from archive with the full abstract, and we can also do the PDF if we want. Okay, so we'll go back here and we've got cross-language toolbox for parallel, linear unbiased estimators, semi-definite programming. I don't know. This is all very, very, very specialized work. Let's see if I can find one that looks a little bit more amenable to a general audience here. Let's see if I can find something that's more normal than that. Oh, here. How about origami motif? Where'd it go? Whatever. I'm just going to choose one to show you the next step, and then we can do one together. We're going to lasso select a couple of articles. What I'm doing here is I'm saying, okay, I have focused down the space using keywords, using a repository I'm going to query, using categories, large subject categories of math and computer science. By exploring the space, I have now found a couple of articles that I care about. And these articles represent not only a subject domain that I care about and am probably expert in, but they also represent a space where I would like to do research. I would like to make a contribution in this area. Maybe I have already, done something here, and I'd like to see what the algorithm produces as a suggestion for what could be the next step in this space. I've selected 2 reference articles. Let's go to the next step. Next step that happens is the algorithm gets launched, and based on those articles that I've chosen, and also their context, because remember, those 2 articles were chosen because they contain the word optimization. But each of them lives in a high-dimensional space in the language model, and it has a lot of neighbors that don't contain the word optimization, but that do contain other information that's relevant to that topic. So, okay, it took a little bit of time, but here's the result. So we have a couple of clusters that are not returning any yellow points. And we have one cluster that has a bunch of them, 39. So this is the result of the algorithm. The algorithm is saying these are the locations in this space, in this subset of articles, where we think that it's likely that you're going to get a high value article. So this is the same algorithm that I was using to produce those two graphs that I showed you before, with the blue curve overtaking the red random line. So my claim, which is, from a certain point of view, very futuristic, maybe hard to believe, but which I'm statistically validating, so I'm proud of it and I feel like it's robust. My claim is that if you write these articles, these 39 articles, you're likelier to produce a high impact contribution to the science of this domain than if you stay within the distribution of the blue, the existing articles, or if you just randomly cover the space. So you can see that there's a lot of empty space here. You could go lots of different places, but I'm saying you should go here. Okay, so it's clear that part of this is, secret. I don't want to tell you, but it's also, I also want it to be as useful as possible. So this is already an app, you can already use it. And I'm going to give you all free code, free for first 10. And you can use this code. You'll get to even do 39 if you want, whatever amount you want. You can also do the small number for a smaller fee and a faster production. This will produce abstracts and titles for the articles that may occupy these spaces. So let me try and explain how that is done, because this sounds really futuristic, but it's actually not that hard to understand. So if we create a language model that has a bunch of words that point to spaces the vectors that point to spaces which represent words and sentences and paragraphs, and we say we've got this cluster in one place and another cluster in another place, and I'm saying future research is probably going to happen in the middle somewhere. Can we characterize that location in latent space using words? Because humans understand words a lot better than they understand a vector in 1,000 dimensions pointing to some point, right? Turns out that you can. And it's actually not that hard to understand how. Basically, what we do is we take a model. You can make a language model that's an embedding model. So you take words and you translate them into a vector. Well, you can also do the inverse. You can take a vector and turn it back into words. And if you do that, the first time you do it, it's not very good. So you're going to get your actual vector is pointing here. You get some group of words. If you re-embed those words, you get another vector, but it isn't pointing in the same exact place as the original vector. But no big deal. Measure the distance, use that distance to optimize the text and redo it. And just do it a couple times, do it 20 times. And bit by bit, the vectors coincide. And then you have words that coincide with that original vector. Okay, so this is what I'm doing. It takes a while because that process is iterative and it takes a couple minutes for each one of these topics. So I'm going to launch this, and maybe as we're talking, we're going to get something coming up. So it's all on Stripe. It's all legit. So I'll show you that when the email arrives. But in the meantime, what I'll do is start to take some questions. And what it'll do is it'll produce the description in an abstract form of that location that the yellow point was indicating, or the yellow points. What's this good for? Well, it jogs your memory. It gives you ideas. It puts together, so it juxtaposes things, perhaps, that in the mind of the scientist weren't necessarily. Thanks for the question. I will give you the floor in like 1 minute and 30 seconds. So it's giving you, it's juxtaposing concepts that you might not have juxtaposed in your mind. It might even do more than that. This is something that we're ongoing research, trying to see what else does the language model contain? What knowledge does it contain that maybe we can surface in this way and get novel insights? Because what all the existing scientists have done doesn't cover all of the spaces that the language model contains information about for other reasons. And I guess I'll just stop talking for now and start taking questions. Madan, what's your question? Go ahead.
So I'm not sure the people that can from remotely they can set up question because it's view only.
Oh.
So maybe they try to text on the comments if it's possible. If not, Madam, just send me a DM, Leo Manfrini on Discord, and I will read your question.
All right, that's cool. Anyone there present who has a question? Yeah, in the corner on the right, corner of my screen.
Thank you. That's fascinating research you are doing. And I was wondering, it seems to me that you are mapping out the potential fields of research that are currently explored. And it seems that you're also mapping out, by extension, the way the global research or even works or operates, what kind of research has been prioritized over others. And is it fair to say that what you're also mapping out is...
I can barely understand. Would it be possible to come closer to the microphone?
Yeah, come here.
Thank you. Sorry.
Can you hear me all right?
Yes, much better.
Well, so I was quite interested in your thought experiment, what you were saying, we can reverse engineer the vectorization of words to eventually go back to formulating words and describe what research we could do. If we apply similar thought experiment to what you're mapping out with Innovation Lens, is it fair to say that what you're describing is how the collective consciousness or scientific consciousness operate in that? These are fields that are being researched over time, but for some reasons, some fields are not researched. What does that say about the collective scientific knowledge of the world, and how could maybe your tool could be reverse engineered to better understand how the collective mind works?
That's an interesting way of thinking about it, and I am going in that direction to some degree. It is part of the modeling is a time series, right? So, and the time series contains moments of fullness and moments of emptiness, and those are both important signals. So the fact that science has concentrated on certain topics and then concentrates on other topics and then sometimes comes back to the previous ones was a feature I noticed in archaeological research for the first time, because what I saw was that the information is very sparse, right? In archaeology, it's not very often that you get, or it's relatively rare that you get a very big discovery. And when you do, people will talk about it a lot, but then they sort of exhaust its possibility after a time, and they don't talk about it anymore for a while. And then another discovery is made, or maybe a connection where that becomes relevant again. And you can build a graph model of this, which is really fascinating. And you can see how each discovery, like each sherd of pottery, is like an atom that is connecting to another atom. And over time, a very high level discourse can be created. So it's actually an interpretation of what all those atoms mean. You know, what story do they tell? So I built from that idea to a more general idea about science in general and about human thought and civilization in general. I don't want to be too arrogant with my project. I don't think that I'm uncovering the structure of the universe and of philosophy and human thought in general. But I have found a somewhat predictive signal, and I think it does go in the direction that you're talking about. That it shows that there are patterns within human learning and human exploration, intellectual exploration, that can be studied and known. Yeah. Thank you.
Do you have some other questions from the crowd? Yeah, please.
So your yellow points, is that just sort of like on the edge of the density map, or is there some other heuristic there?
Well, you can take a look at the picture again and see that it's not on the edge of the density map. Let's see if I can. Yeah, I encourage you to play with it. You're welcome to see if you can reverse engineer it yourself and figure out what I'm doing. It's not banal, but it's also it's a let's see if I can show it to you again here. Oh, I have to share. Yeah, this is the part where it's hard to avoid like giving away the secret sauce, and but I get excited, and so I'm going to share again, and we can talk a little bit more. Oh, I might have chosen too many articles. It'll take some time, but anyway, no. Okay, no high-value research topics were found in your selection. Okay, so there's a part where didn't find anything. Let's choose a couple here, see what they give me. So what I'm doing now is I'm looking for subject matter experts and calculating these predictions for them and asking them to to vet them, to say what they think is useful, what is not, and so forth. Okay, so you can get to this point for free. You don't have to pay to see this map, and you can look at what you're getting, and you can also look at the articles around. They have their full information here, so you can also derive some interesting insight just from this map by saying, okay, I've got a lot of things clustering around whatever these articles are.
Right.
So presumably, whatever these are is going to be something like a combination of what the other ones are, right? So
I guess high citation based on your previous thing.
Sorry, what?
I'm going to guess high citation count.
As a metric, as a predictive metric?
Yeah.
Actually, that doesn't play into the algorithm at all. So
Interesting.
Yeah, John, we have like the question from the remote friend.
yeah, go
So
ahead.
Anna is asking, what other domains or applications are possible by applying this technique? Can you give some examples outside research papers? In other words, where else can we apply similar techniques?
Yeah, that's a great question, and that's the one that all the VCs ask me. How can we make more money? Because like if we're selling this for $5 to researchers, it's just not going to make me rich. So I think one useful place is like expand the research idea to people who have a lot more bandwidth and could do a lot more with big numbers of predictions. So one of those would be granting agencies like National Science Foundation in the US or things like that. Another one would be hedge funds. If you're trying to predict future development in markets, that is to some degree correlated with scientific discovery. So what can you predict? And how can you apply that knowledge as a vector inside of the algorithms of a hedge fund? That would be something. I'm developing that right now, just an API so that they can make a call and get all that information every day if they want. Another space that this could be interesting is patents. Maybe we can predict other things besides scientific research, but that have a similar structure. So patents have a similar structure in the way that they're written and also in the way that they, like you don't have new patents that are on top of old patents. Because if you have a patent, like by definition, new patents have to be somewhere else. They can't be in the same place. So it's similar to scientific research in that sense. Those are a couple of use cases. I think there are others as well, which look like from my perspective, they look like scientific research, but they could be extremely lucrative. Think, for example, pharmaceuticals, drug discovery, places where scientific research becomes extremely valuable for one reason or another. Yeah, so then I'm sure that there are probably other things too, like for example, insurance or marketing. There might be other domains where a large network of text information could be queried in this way and could be predicted in some sense. Those are data sets I don't have access to. And so I started with scientific research also because I can get 40 million articles off of PubMed and arXiv and work with them. I'm not sure where I could do that with other domains, but I'm looking for people to collaborate with. So if you know somebody, let me know.
Thank you. We have another question from the crowd, another couple.
Yep.
Hey,
Hey, mate.
Hey.
I think that was kind of like my question, but my question is, if I want to apply this for other topics, I mean, yeah, that was kind of my question. So what if I wanted to learn about blockchain or economics or even the, changing world order? You kind of answered it, but when can this be available for those things, or is it part of your roadmap? Yeah.
Why don't we do a live test right now and see what we've got? Because I think we've got something already, but I don't know. So I'm going to go look. So, and you can do this on your own computers. It's not very good on mobile, but it does work. Anyway, so I'm going to go to, let me do this slowly so you can see. I'm going to go to Archive because I know that Archive contains an economics repository. So let's pull up econ. Let's also do math. Maybe there's something about blockchain in there. And then let's just do blockchain. Would you like to specify anything further, or do you want to just do that?
Yeah, and do decentralization.
I'm going to just do a little part of the word. It's a string match. So if it's decentralized or decentralization, it'll get it both ways.
In fact, in that case, are you able to do it without the Z? Because there might be UK
Good call.
as well.
Good call. How about that?
Fantastic.
Okay. All right. Let's go. Let's see what we got. All right, we've got some stuff. Okay, that's interesting.
That is actually a huge trend in blockchain right now. Decentralized physical infrastructure, ledger model.
Yeah, so you've already got 100 articles or something in here, and then if you want to know, like, find something that you care about, just circle it and run the inference and see what you get. Okay, I don't have enough information, or there isn't anything in that area. We can try another part here. Unfortunately, the front end is a little bit janky still, and you're getting colors changing when I reload the page, but sorry about that. I don't know, is there a specific topic that looks interesting to you among these?
I think, yeah, do the monetary effects, if there is anything.
Okay. Monetary policy, digital assets, and DeFi activity. Sound good?
Yeah.
Okay, let's do it. All right. Oh, nothing up in this cluster, but I have something down here. Okay. All right. So topological data analysis for portfolio management of cryptocurrencies. That sounds pretty cool. Optimization of portfolios with cryptocurrencies. Yeah, so then you start to study, you start to think, what is all this stuff and how could it possibly bear on the questions and interests that you have?
Awesome, Jonah. Awesome, mate. Cheers.
And Jonah, I have a note on that because so as Hegel says, I studied like philosophy and Hegel. So basically, the egoism of people comes first. So probably, having access to different type of data for economic purposes would be better, because I think research doesn't follow like exactly. So it's like a circle. So scientific research anticipate economic trend, but at the same time, the practical egoism of people for getting richer and richer, they are experimenting more on the practical field, and the research is not yet there, right? So I think it's interesting to potentially try the framework in a different data set, maybe like the hedge fund type of things, because they have access to like large amount of data from startup and stuff.
Mhm.
And yeah, it would be like really, really cool also for investment purposes. But yeah, we have another question from the crowd, and yeah.
Yeah, go ahead.
Hello. Yeah, I have a question. Actually, my background is biomedicine, and I noticed all your articles are sorted in 2D format. What I mean is, for some field for some research, it may intersect with many areas of study. For take the gene regulation as an example. One gene regulation might be related to immunity to a certain kind of disease and to some signaling pathway. This creates a complex network of connection. I mean, how will your model handle this type of research with multiple interconnections?
That's a great question. And I think at this stage of development, I'm not taking into account to a very great degree. But I can say, I guess, two things that relate to what you're asking. The first is with compute power, with a bigger team, with some money, with better data, I can see a pathway that goes in that direction using a graph representation. So this is, right now, I'm using a simplified representation because it's within reach of the resources that I have. So that's one thing. The second thing is, one of the great things about language models is that they do contain information in a way that represents the multi-dimensional branching of information that you just said, which is kind of the magic of language models, because it's not obvious that if you embed words into a high-dimensional space, you're going to also get the polysemic nature of words, that a single word can mean many different things depending on the context. But that is the magic of the transformer and the word embeddings that we have today. So that makes me confident to say, even though I'm not explicitly modeling the multidimensional connections between sources of information, but I'm only using words as my basis, some of that information that is highly structured is still being returned in the results.
Oh, okay. Maybe in the future, will you consider the 3D format? Because I think maybe it can show the interconnection better.
Yeah, well, I did. That's interesting. In the first iteration of this website, I did use a 3D representation, and I simplified it because the users were finding it too hard to understand. And so I'm trying to please the user, and I'm finding that whatever I do, it's wrong. So I have to make a choice, and in the end, I just make one. But yeah, that's a good point. I would really like to apply this in a scientific domain where people are more sophisticated, so you can use higher resolution information. But yeah, thanks for the question.
Okay, thank you. I looking forward to your better 3D format. Also application in the biomedicine. Thank you.
This is applied to biomedicine. You have all of PubMed on here.
Okay, thank you.
Yeah, you can already use that.
We have probably another couple of questions. Yes, Stefan. I'm here close. Thank you. Okay, Renat. I was wondering, would it be possible to replace research topics in this graph with public discourse or public discourse topics? And if we cluster these public discourse topics in terms of the intensity with which they are explored versus the impact that they have or the clarity that they have. And then on the other hand, we have other type of public discourse which are maybe not very well explored, but could have potential huge impact. And use this type of graph to identify possibly the collective emotional biases or potentially political manipulation. So this topic has been explored and again and again and again. Mm-hmm. And without much clarity,
whereas this particular question hasn't been raised, whereas it could have a lot of meaning. You see where I'm going?
Yes, yes. Maybe I can just show this. Yeah, it's still up. Great. Okay, so I did something similar to what you're talking about last year for the European Union, and I did it on the question of conservation of the soil. So it was a European Union funded project, and there were a couple of different aspects of it. But anyway, one thing that I did was I created this knowledge map. Let me just share this with you because it's similar to what you're saying, and it shows also the result that you get. So what you're seeing here is this is time. So for our friend from before, this is a three-dimensional representation, a similar kind of method. Time from -700. So this is like Homer and the Iliad, the Odyssey, and here we've got like Beowulf and the Divine Comedy, and then more modern poets. So I didn't have all that much poetry, but I had enough to create this this network. And then what we have, what's this other cluster like way over here? What's this? This is European Union law about the soil. So the representation that I'm showing here, the research question was, how does European Union policy compare with the accumulated wisdom of the European peoples about one topic, about the soil, about the meaning and conservation of the soil. So what this graph shows you is that there's a significant difference. There's a distance between the two. Whereas all the poetry, even by very, very different authors and with very different themes, tends to cluster along, you know, this area. We have policy over here. Now, it's obvious that policy language is very different from poetic language, and so you're going to expect that there's a difference and a distance. But for the purposes of this example, it was just to help you reflect, just to help you think that you can imagine tradition or history or, you know, a single kind of thought being represented by a vertical pillar in this space, and a different thought is a different location, right? So my answer to your question is yes. I think that using a representation like this, or a more sophisticated graph to represent political discourse or philosophical discourse or something like that, would be a very interesting and useful way to act. I also think that the people who it would be useful for aren't interested in general. So my experience was that it's like, yeah, it is helpful if you care, but caring is the main point.
John, I have there's another question, then I have a final question.
Yep, go ahead.
Can you just show the example of the paid output? Is that generated, or do you have a pre-generated one?
Yes, I can. And it is here. Okay, so let me open this. It's not a beautiful email, unfortunately, because I still haven't built the beautiful part, but here it is. Okay, so what did we get? Okay, we got one that's basically a dud. And then we got computationally efficient solution to prior Gaussian equations through spectral reconstruction and spectral inversion. In this article, we propose a solution to the previously unsolved Gaussian equations. Of course, you have to be a domain expert to know if this is even realistic, right? And I'm not in this case, I don't know. But I encourage you to give it a try on subjects that you do know about. And you can use that free number 4 first number 10 to give it a try with a free coupon.
Cool. Thank you.
Yeah.
John, so I have like a final question / challenge, let's say, which is, so one of the reasons why I think Western academia is over is hypertrophic hyperspecialization. So we miss real cross-disciplinary things, and so my challenge is how your work can be applied like for this purpose, for the unity of knowledge, for bridging like topic and languages that are really far from each other, and not just like helping scientists to just hyper specialize on the next topic. So that's the question / challenge.
Yeah, I mean, that is part of my motivation here. And if we go back to the map page, I can sort of give you an intuitive understanding of what I mean. And while I'm doing that, I'll try and give you another answer too, which is that the reason I believe that the reason I believe that interdisciplinary is important is because I think that humans explore space. We are not ever happy to stay put where we are. Well, there's a percentage of the population that is happy to stay where it is, but there's always a significant portion of the population, maybe it's 20% or something, that can't stay still, that has to explore. And we explore space, we explore ideas. We aren't happy with hyperspecialization, so let's do biophysics. Let's use that as an example, and maybe prosthetics is the domain where this is most obvious. At the intersection between specializations, my tool is a way to look for. So these are articles that are categorized in physics and in biology, but they're very close. They're very similar within this mapping, and that I think is an aid for interdisciplinary work. Because if you're just reading physics articles, you might not know about these bio articles that are very close to your work. So that's and to see it visually is helpful, because then you can say, oh, those two things are close, they must be alike in some sense. But what you're also pointing at is a bigger question that we don't have time to face, but I think I'll launch it back to you as a challenge, which is the challenge of philosophy, right? The challenge of wisdom, the challenge of what is good and beautiful and true. How do you navigate within the space? What I've been showing you is a tool which is a way to see things that you couldn't see otherwise, because they're represented in a way that's intuitive, and then they also translate back from the math into words that you can understand. So that's a tool. It's an intellectual prosthetic, if you like. But the question that you're asking goes farther. You have to also ask which directions are desirable, which subjects are good to explore, and which are maybe better not to, right? Even though sons of Prometheus, we tend to explore all the spaces, whether or not they're a good idea to explore. So I think you're asking the fundamental question of philosophy, like how do you know, what's your compass? Where do you go in the space of possibility? So maybe we can talk more about that.
You're right. So I'm a philosopher by formation and by DNA. But let me close with a funny fact and let the people go, because I do believe I value people's time. And I think I come from like a philosophical tradition which says the first technology is the finger. The finger that like points to the sun, to the moon, and make a difference. So the language start there. So with the finger pointing an object, the sun, the moon, and everything. Right now, all of these vectors, math, AI, they're basically a more advanced finger for us. And it's pretty cool. So this weekend, I was doing the Learnathon myself and was playing around with an app that a guy here like suggested to me called Brilliant, and also Balaji is using. And it's super cool. So I was learning about vectors, and it reminds me like the finger. So I do believe that sovereign learners, like sovereign explorers in the next stage, will be like people, they need like just two tools. A map to navigate like a novelty, like you are creating, and a finger to point to the horizon to go further. So I want to close with like this kind of exploration metaphor. And thank you so much for giving us like this map and trying it out. And I mean, I would be really happy to having more ID for collecting more questions from the crowds, async, and like forward it to you. In the meantime, thank you so much, everyone, for being here. Thank you so much, Jonah, for the amazing speech, and for the people taking part of the Learnathon. I do remember that this is the last day, so the deadline for submitting your artifact, your model, your GitHub page, your learning log is like the pizza party at 6 p.m. And if you don't have enough experience point, bring your wallet because the pizza is not free. So thank you so much, and have a nice day, everyone.
Thank you, guys.
Thank you so much, Jonah.
So can I send you the code and link to the LinkedIn page so that people can follow us?
Yeah, definitely.
Right.
I will forward the code and everything to the people they got into. And yeah, thanks so much. And yeah, let's talk async regarding the other topic we were discussing in the
absolutely.
beginning. And I've seen on LinkedIn you were in a road tour of Silicon Valley with some cool picture at Google, NVIDIA. It was fun.
Yeah. Yep. It's great. I'll be going back next week, and then I've got some conferences in Europe.
Amazing. Okay. Have a nice day, Jonah.
Take care.